All right, so part 2, we're picking up where we left off. So we're going to go ahead and keep using our exponent rules. So our next problem, negative 24, p to the 20th, q to the 12th, divided by 8p to the 4th, q to the 18th. All right, so we just, first we need to look at what operation are we using. So it's a division problem. That fraction bar tells us we're dividing all that stuff. So we're just going to go ahead and go in order and divide by like terms. So negative 24 divided by 8, negative 3. And then we look at our p's. So anything with like bases. Now when we're dividing, remember, p to the 20th, that really means I have 20 p's in the numerator. P to the 4th really means I have 4 p's in the denominator. So if we cancel stuff out or use the subtraction rule, 20 minus 4 leaves us with p to the 16th. Now, when you're going to the next one, there's 2 ways you can do this. So you can use your subtraction rule, but I really like to think about this so that there's something that I don't have to do in the end. I like to look, where are there more q's? Are there more q's in the numerator or more q's in the denominator? Well, I have 18 in the denominator and only 12 in the numerator. So if I subtract 12 from 18, I'm left with 6. But where are the 6 q's left over? They're left over in the denominator. So over q to the 6. Now, why did I do that? Well, because everything, all of my exponents, they're positive. If I would have subtracted them 12 minus 18, I would have ended up with q to the negative 6. And remember, we're not allowed to keep negative exponents, so then I would have had to move it from the numerator to the denominator to make it positive. So this way I just ended up with everything in simplest form automatically. I didn't have to rewrite anything. So when you're doing these problems, oftentimes there is more than one correct way to do them. So, and still get the correct answer. All right, our next one. Negative 3x to the 6th, y to the 4th, and we're going to cube the whole thing. So what rule are we using? What's the operation? Well, I have one term, and I'm cubing the whole thing. So we're going to have exponent to exponents. So what I need to think about, first, I've got negative 3 cubed. So negative 3 times negative 3 times negative 3. So negative 3 times negative 3 gives me 9, times another negative 3 gives me negative 27. Now, again, exponent to an exponent. So technically I have 3 groups of x to the 6, or 6 x's. So 3 groups of 6 x's would give me how many x's? Well, hopefully you just came up with 18. Or you can use your shortcut and say I've got an exponent to an exponent, so I multiply 6 times 3. Whatever works for you works for me. All right, so let's do it again. I've got 3 groups of 4 y's, which gives me y to the 12th. All right, are all of my exponents positive? Yup. So I don't have to simplify. Well, I'm already in simplest form. Awesome. If at any time you're having an issue or you're not following something, pause and ask your partner if they can help you, okay? That's why we sit in groups. All right, so our next one. Negative m cubed n to the 4th to the 4th. We got a lot going on here. Minus 8m to the 12th n to the 16th. Whoa. All right. Now, when you read this, you look and you're like, okay, negative m cubed. Well, that negative is technically a coefficient out front. What is it? Negative what? Well, hopefully you said negative 1. So really, I have negative 1 to the 4th. Now, how we're going to simplify this? Order of operations. Exponents always come first. We are not subtracting this stuff until we simplify the exponents. So negative 1 to the 4th. Negative 1 times negative 1. 1 times negative 1. Negative 1 times another negative 1. Positive 1. So positive 1, you can write it or not. It does not matter. I'm going to go ahead and write it because it might help me later. Who knows? All right. So now, we've still got exponent to exponent. So m cubed to the 4th. So my exponent rules tell me when I have an exponent raised to an exponent, I multiply. So 3 times 4 gives me m to the 12th. Again, or you can think about it of m cubed tells you have 3 m's, and 4 groups of 3 m's gives me 12 m's. However you guys want to think about it is fine with me. Whatever works for you. And then n to the 4th, so exponent to exponent, multiply again, n to the 16th. All right, so I've simplified this first term. Now let's go ahead and subtract 8 m to the 12th, n to the 16th. First thing I'm going to ask you, can I combine these terms? Are they like terms? That's what you need to be thinking about right now. So, like terms, same variable, mn, mn. All right, halfway there, but that doesn't mean they're like terms. Like terms have to have the same base and the same exponent. So, since these are both m to the 12th, n to the 16th, they are like terms, so we can combine them. So if I have 1 m to the 12th, n to the 16th, and I take away 8 of them, how many are left? Well, actually, none are left. We're taking away more than we have, so it becomes negative 1 minus 8, negative 7 m to the 12th, n to the 16th. Sweet? Hopefully. If not, I will answer questions tomorrow. But if you have questions, go ahead and write them off to the side so you don't forget them before tomorrow. All right, last one. Negative 6a cubed, b squared, quantity squared, divided by 4, a, b to the 11th. So again, we have a lot going on. We need to think about what are we going to do first. Well, order of operations. I need to apply this exponent. Crap. Sorry, I had to pause. So, we're going to do this exponent before we can divide, because again, PEMDAS, exponents come before division. So let's go ahead and do negative 6 squared. What's negative 6 times negative 6? So I've got 36. Now, a cubed squared, so exponent to an exponent, we multiply. So a to the 6th. And then b squared squared, so 2 times 2, b to the 4th. And now let's go ahead and divide all of it by 4ab to the 11th. Okay, so hopefully up to this point that was okay. So now let's go ahead and do our division. So one thing at a time. 36 divided by 4. Oh, awesome, it goes in nice and even. We're left with 9. Now, these a's, this a in the denominator, how many are there? 1, so I'm going to go ahead and write in that exponent. So when we're dividing, MADSIM tells us dividing, we subtract. So 6 minus 1 leaves me a to the 5th in the numerator. So again, my b's. When I subtract those, I want to think about where are there more. They're more in the denominator, so b to the 11th and then b to the 4th. So when I subtract 4, I end up with 10, 9, 8, 7. So 7 b's where? In the denominator. And I'm in simplest form because I kept all of my exponents positive. If you would have subtracted from the numerator, you would have ended up with a -7 on the numerator, so you would have had to take the reciprocal to make that exponent positive. There are tons of examples that you can do for these. I cannot get them all. So these are just a few I wanted to start off with. So go ahead and tonight you'll be doing homework from day 4. So you'll be looking at those commutative and associative properties. Tomorrow in class, we'll be doing some more practice with the exponent rules. So we'll pick up here. All right, have a great day, guys. See you tomorrow.